How are you doing Monday night? And it is the Physicist and Philosopher Hour. The physicist is Dr. Claudia Albers. And
Mhm.
hello, Claudia. How are you?
Hello, Wayne. I'm fine, thank
Good.
you. And you?
Hey, doing good. Experiencing, I guess, this really topsy-turvy weather.
Oh,
I have
yes.
a brother that lives in Seattle, and they are getting clobbered. In fact, I pulled up a article just on how much
Mhm.
snow. In fact, I also have showing what looks to be coming in this weekend could be something epic. So anyway, how is your world out there? Is it cold still?
It wasn't too cold this morning when we went out, but it was snowing. No, there was snow on the ground, but it was raining.
Oh,
And it actually helped me a lot with the current article that I was writing because I was observing what was going on, what the sky looked like, and because
yeah.
I as far from what I've discovered, all this water that's coming down as rain, snow, it's not actually Earth water, it's Planet X water that's coming down. Water from the Earth comes from below, not from above. Planet X water comes from above and rains down as snow, hail,
Oh,
rain.
I'll tell you. Talk about hail. They had the Pebble Beach golf tournament, and the craziest weather I've ever seen. Crazy, crazy. I
Mhm.
mean, it's just nuts. I just want to say hello to everyone in the chat room. Thank you, all your moderators.
Mhm.
So I think that, speaking of which, we've got some really great viewers. Cindy, who does probably some of the best work. I want to show you what she has sent. It validates to me, Claudia, that the Earth has moved. So we can get the date on here. This was the back in February.
Mhm.
You can see the date.
The fifth, yeah,
Mm-hmm.
the 5th of February.
Watch 2018, right?
Mhm. Mhm.
Same picture, same time, and
A
I
year
don't
later.
look at that. Now,
Wow.
so I don't know. What do you think, Claudia? You think that and I'm going to pull up another one here. So
Well, I don't think it's the Earth moving. I think they just cannot keep it correct.
keep it in the right place.
Yeah, I think it's a simulator, of course, and the whole thing is a simulation. So they just not able to keep it in the right place for all observers on the surface of the Earth. That's what it is.
So look at this one. Here's 2018.
Mm-hmm.
This
There
one
it
I
is.
thought was even more profound. Now what?
Sometimes it changes dramatically from one day to the next as well. You know that.
Mhm. I just thought from year to year, it's obviously something has appears to me
Something
that
has changed, but
yeah.
from all the evidence that I've seen, the sun is not shining at all. So basically, we're working off of simulators and have been for many, many years. I wrote one little article putting all the information again together. Since 1998 already, they had simulators in the sky, no real sun.
Well, I know that the sun has changed. I know that I can feel it on my skin. And that's what I really go by. I used to
Mhm.
do a lot of, in my youth, used to do a lot of surfing, was enjoyed it.
Mm.
And I see that, April. Okay. All right. I'll check that into it. So, anyway, excuse me. So, I think the sun has changed.
Mm.
Um, it appears to me that it's changed. I think there's dramatic changes on the earth. I don't know if the earth has begun to tilt more. I'm seeing mainstream people now pretty well admit that we are in the middle of a magnetic pole reversal. I believe that. But what do you think?
I think it's a little bit more serious than a pole reversal. I actually think the Earth's core seems to be splitting. I've written some articles about that. And I have written many articles that what's happening with the Earth is way beyond what accepted physics and science. All the sciences are telling us is happening. They're trying to make it seem a lot less dramatic than what's actually happening. Like I said before, I have overwhelming evidence that shows that the sun has not been shining for many years. It's just not able to. It's now too weak because of the Planet X system stellar cores that have been coming into the solar system for thousands of years now.
Well, I think science may be a little behind you, Claudia, but
I think they are way behind.
I think you are. Well, I want to pull this up here. Folks, it's about to get interesting for all of us here in the United States. Want to show you, this is the upper air current. This is the polar vortex. And Claudia, what I wanted to show everyone is really what's coming down the pike. I think this is going to be epic for us here in the United States. This is really unprecedented in many ways. Right now, Seattle is getting hit. I have a brother that lives up there. I was telling you about it. I think when I spoke to him today at noon their time, I think he said there was already 14 inches on the ground. They're expecting another foot to another 15 inches. That's unprecedented, Claudia.
Yes.
And models are showing that as this moves through, next weekend could become very interesting. So, Claudia, I wanted to show you this. Do you know what President Trump just did? He signed an executive order right here directing federal agencies to prioritize research and development in artificial intelligence. This is a move much to like what China is doing, moving all systems, everything to AI.
Oh, yes. Very interesting. Yes, I think the whole world is moving in the same direction.
Yeah.
It will. It would. The controllers, behind the scenes are the ones that are leading to this occurring.
Yeah, I happen to think we're in unprecedented territory, Claudia, just me.
It's very dangerous, but, it cannot be stopped.
I don't see it either myself. You and I agree on this. Did you see this story here on what's happening in Antarctica?
Yeah, I wrote an article about it.
Pulling it up. So just thought, that this is more evidence that something, as they're saying right down here on this story, something's ominous happening down there in Antarctica.
Yes, I think what is happening is that the ocean level, the sea level, is going up. It's increasing.
I have your article on that too.
Yeah, so I think they're trying to come up for an explanation of why the sea level is rising.
Yeah.
And so their explanation, because they don't want to bring Planet X into it at all, because they want to keep that a secret that it's occurring. They don't want the Earth's population to know about Planet X. So they come up with different things, like the Earth's doing it to itself. So they came up with this explanation. But as I showed in my article...
we have that article.
Yeah. I don't know if you want to pull it up later, but...
Yes, it is in the queue.
Okay. But as I showed there, this article here doesn't make any sense.
Well, when you read it, you know what I figured out?
It's scary. It says, oh, well, this huge cavity appeared under the ice in 3 years. When you use the rate at which the melting has occurred, to calculate how long it would take for this glacier to melt, it will take 47 billion years. So it cannot be the melting of the ice. It cannot be, because at the rate, I mean, they'll say, oh, look, this cavity formed, it's this large. Yeah. But are these scientists even writing this? Did they actually calculate the rate and what it means in terms of the sea level rising? Because I did. And what they're saying is illogical.
You're going to prove that out here as I pull that up.
Oh, yes.
By the way, I just wanted to show this to all the women out there. So no matter what your age is, if you're married, dating, have a significant other, and they're male, you can look at them and tell them you're still 4 years younger than they are, Claudia.
Oh, that's nice.
You know, so this is, and trust me, I think as, you know, we all get older, that's important. Here's one I thought was really interesting, Claudia, is that now, you know, we were all raised with the idea that the Milky Way is flat, right? You look at it from the ecliptic plane. Apparently not.
Very interesting.
This is the composition, as you can see over here, that they have now. This is from China and Australia. This is the 3D map of the Milky Way. And what they're now finding is that, Claudia, it's warped.
That's very interesting. I mean, if we haven't observed this sort of thing in other galaxies, we could deduce from that there's something different about the Milky Way galaxy. What happened to it?
That, my dear, is a question that is becoming more and more relevant in science, particularly in astrophysics. I mean,
yes.
Our universe is changing, Claudia. You know, when you postulate your theories, to me, I figure it's like this. Science, and I'm waiting for the time when someone starts writing about it. You know, when they start using your reference material. I think it's going to happen, Claudia. It's just me.
I hope so. Sometime I'm sure it will. I'm not sure if it will in
your lifetime. No, I think
my lifetime, but yeah, but anyway.
I found this article interesting. This is the university. I think this is Newcastle. We talk about the sun all the time. You have clearly stated that the sun is diminished. It has no more energy. They're finding so many new things about the sun, Claudia, that I think they're going to have to redefine the physics itself.
Yes. Yeah.
They said
that I'm sure they're finding new things because the thing is, whatever they're finding, because they will never admit to the existence of Planet X. And without admitting to the existence of Planet X, they will never be able to explain what the sun is doing. So no matter what they come up with, it's just something to entertain the minds. It's nothing to do what's really going on. That's my view on this.
I happen to support that in many ways. Here is the drought. This was real interesting in California, where look what happened. These were the small little inconsistencies that no one was paying attention to, the little small quakes. This is actually, I've been on this highway, and this is what happened, Claudia. It just slid right out.
Wow.
Yeah.
My goodness.
And this is how you could see what happened. So the slide took place here, but this is where the activity is. And so, Claudia, I'm telling you, it looks like things are changing. How about this one? I just wanted to bring this out. We live in a world, as you say, an observer can begin to see. They're having redefining what the cognition of animals is. Apparently, they're a lot smarter than we think.
Yes, they are. I agree with that. Animals are extremely intelligent, and they are able to interact through language. It's just that they are not able to speak because they don't have the same vocal cords as we do. But chimpanzees are able to interact through sign language. And I think other animals, like my little dog, is so clever. He definitely understands words.
Yes. Yeah.
So I agree with that. Animals are extremely intelligent.
We live here in Colorado. And when I moved here from Texas, one of the first things I had to get used to were ravens.
Uh-huh.
And Claudia, they're very big birds, but they are smart. Mm-hmm. I mean, these birds, I think they're smarter than some people. Just my opinion.
Yeah, but that's very likely.
Yeah.
I think animals are much better than AI. They basically smart biological AI units.
I agree.
Well, not quite artificial. I can't say artificial, but intelligent units.
You know, you look at the eye of a raven, yes. I swear you see intelligence.
Yes, definitely.
And as you said, even with my dog, I mean, I swear that dog is smarter than me at times. Here's one. The booms are back. Apocalyptic sounds in the sky. Happening all across the United States. Mystery booming sounds.
I don't know what's causing them yet. I haven't figured that. I haven't actually looked much into it. But if there are booms, there must be a reason for the booms.
Well, they say here, this is what's being different now. They said that the resonance, they're hearing it after flashes of light were spotted across the skies. I am wondering if they're testing a new jet, a new propulsion system. Mm-hmm. Sonic booms, would you think?
Yeah, well, it's possible, but it's also possible that it has something to do with the Earth.
Yeah.
I've written a bit about sinkholes and how it's actually an object in outer space it's a large stellar core that interacts with the inside of the Earth, and it causes the Earth to move away from it, move its matter energy level down, all the way down in the outer core. And that causes a whole cylinder of the Earth to move straight down into the core, and that causes the sinkholes. But it starts with an object above the atmosphere. So we could have something happening up there in the atmosphere that would lead to the light being given off, and at the same time, the noise actually coming from inside the Earth because there's an interaction across.
Interesting. I love that. So here we go, Arizona to New York, Rhode Island. As I was looking, here is in, again, Brooklyn. Here is in Tennessee, North Carolina. Let's see, where's this one at? Doesn't say. I guess doesn't say where that one is. New Orleans. So it's virtually all around the United States. Everyone's hearing the same thing, Claudia.
Really? And not anywhere else in the world, just here?
Well, this article here seems to be the only one focusing in on the United States.
Because they have been in other places around the world.
Yes. Well, I just wonder if maybe we're just catching up to what's happening in other places of the world. I don't know.
I cannot actually tell you if it's an artificial source or a natural effect. I don't actually know what is.
I'll send you this article.
Yeah, thanks.
Okay. You folks in Seattle, I feel sorry for you guys. How about this? Did you hear about this today? What happened in Hawaii?
No, I've been just busy writing one article.
They had, I believe, what was the amount of winds? I think it was 90 miles an hour, 95 miles an hour. And get this, Claudia.
Oh, my goodness.
This is, come on. Here we go. Here, the lowest level and elevation ever in state history on the Big Island. it is snowing.
Oh my goodness.
Now, my wife and I were married on the Big Island, and but when you start seeing the elevations, they're now below 9,000 feet. This is something's going on.
Yes.
I think it's happening. I think this one really bothered me, Claudia, because I think this is so relevant in much what you write about. I'll be on a gentleman's show tomorrow, Forbidden Knowledge's channel. And anyway, he lives in Louisiana. And what we have been seeing, and now it's becoming confirmed, insects around the world are becoming extinct. I'm smart enough to realize that in any part of the food chain that begins to collapse, that has a tendency to collapse the rest of the chain.
Yeah, that would affect birds that eat the insects, I suppose.
Well, as this article here says, if it continues, that by the end of this century, we could be in real problems. I mean, you think about bats. They eat mosquitoes. They eat nighttime insects. I can tell you where I live, Claudia, when I first moved here about 15 years ago, every May, they had what they called the Miller moth. It migrated from the plains and would migrate through Colorado. We don't have them anymore. Last year here, I noticed a distinct decrease in flies.
Wow, really?
Along with bees. Now, when I first moved up here, there's a nuisance. I mean, we live on the plains and so flies have always, they were just a nuisance.
Yeah.
As everyone knows. But in the last couple of years, they have decreased to virtually, I would say it's less than 90% of what it used to be.
Wow, that's amazing.
You see, you said something about the observer.
Yes. Well, it must be affected by what's happening in our atmosphere. And one of the things that's happening is that the radiation's increasing. And, I've written some articles about that as well, that our atmosphere will start emitting more and more radiation as the Earth weakens, because the energy levels will come down further and further down where matter is denser.
This is the evidence right here, Claudia.
Yeah. That's amazing.
And, I'm not an alarmist. I don't like, getting people all riled up, but the evidence is just becoming, and it's, it's the small things, people who fight cancer survivors. The thing about cancer is that it starts with one cell going rogue. And we don't see it until it's reached a critical mass. I think that this is what we're seeing. 41% of the global insect species have declined over the past decade. Claudia, that is alarming.
That is amazing. That's unprecedented. It tells you that we're going through a mass die-off. And if it starts with the insects, we've had die-offs in just about all other species, birds, fish. We've had die-offs in many, many species, but this definitely tells you that there's something going on our planet. And it doesn't surprise me, because to tell you the truth, I'm actually surprised that we haven't had cataclysmic events that result in mass casualties of people, human beings, yet. But I know they are coming, and this is one of the signs that it is going to happen.
I'll send you this article, and because I'd love to see your analysis on that even further. That, I think this is just evidence of something. You're not seeing it in the news. You're not seeing it anywhere. But, and I'm not an entomologist, but again, the observer would tell you that if we're seeing a collapse in one part of the food chain, I think it could get very serious. So I pulled up some of your articles, and I happened to have the one that you were talking about the sea level rising, because I wonder if what we're seeing, Claudia, is potentially well, I think there would be a connection. If we see sea levels rising, we see insect populations collapsing. I mean, this is, I think,
the sea level is rising for the same reason that we had a flood. It's planet X. It's coming in, debris water is coming in, and so there's more and more ocean, and it's causing the sea level to rise. So here I just explain what happens with the Antarctica ice sheet, how it melts from underneath by the ocean, because the ocean's warmer than the atmosphere. And so it melts and it flows towards the ocean, and at the edge it breaks off and you get icebergs. So melting from underneath is natural. I mean, from the article, it sounds like they're suddenly saying that the melting rate has greatly increased. And so this means that this glacier is going to melt and the sea level is going to rise. And they talk about 2 feet for this amount and 8 feet for that. And if the whole of the Antarctica ice sheet melts, the ocean level will rise by 200 feet. And I thought, well, that's interesting. And they tell you exactly how large this cavity is, and that it took 3 years to form. So you can know from that what is the rate at which this glacier is melting. And so I went and I used that. And I calculated how large this glacier is, how much volume of ice it had in it. And I used the rate that they report on at which this cavity formed to calculate how long it would take for this whole glacier to melt. Because the whole glacier has to melt in order for the other glaciers behind it to melt. If this whole glacier melts, it will cause the ocean level to rise by 2 feet. But then the other glaciers behind would quickly follow, and that will lead to 8 feet rise or another 6 feet. So I calculated, this is the Thwaite Glacier. I calculated how large it was, and if we go, that's the area of the ocean. We know that will lead to a 2 feet rise. So from that, I can calculate what the volume is. It's just area times the height. So if we move down a little further, and so that's the volume in the glacier. It's 2.18 times 10 to the 14 meters cubed. And from that, I can calculate the mass just by multiplying by the density of ice. And that's 2 times 10 to the 17 kilograms. And I know exactly how much I had in the cavity. So through that ratio relationship, I can find out how long it would take for the glacier to melt. It's 4.7 times 10 to the 10 years. That's 47 billion years at this rate. Now, can you imagine that? What kind of geographer, climatologist, expert puts out an article like this and fails to calculate, saying it's an alarmist article. Oh, the glacier's going to melt. The sea level's going to rise. But he fails, or she fails to calculate how long it's going to take to rise. Now, I'm sure they didn't do that. This is a cover-up article. This is what they do with a lot of scientific articles that they put out for the masses. It's just propaganda. It's not science at all. It's a cover-up. And it's illogical. It makes no sense whatsoever. And then I said, well, I think this is basically what it is, a cover-up, because we'd expect as more and more water from the planet X system to enter the atmosphere, we would expect the sea level to rise if the Earth doesn't expand at a certain rate to keep it the same. So obviously, they have found that the sea level is rising, and they're trying to cover that up. And then I say, well, if the sea level is rising, you would expect small islands to just disappear. And there was a report of an island in the north of Japan that just disappeared last year. So we know that it is happening. Now, it's possible that islands will appear as well because the Earth will be expanding in places. But the fact that they will be disappearing like this, it's most likely because the ocean level's rising.
Interesting.
Yeah.
That's 47 billion years, huh?
47 billion years. And what I say is, even if it starts happening at 1,000 times faster, it will still take 47 million years. God. This is ridiculous, Wayne, that they put out an article like this. It's absolutely ridiculous.
I'll put that on my day timer. I found this one really interesting. Mm-hmm. The Van de Graaff generator. This is, how did you come up on this one? This one I found very interesting.
Well, I've been thinking a little bit about free energy, but this is again about the water that's coming in, the debris water, which is Planet X water. Like I said, Earth water comes from underneath. And that will be declining because the Earth is losing energy. It's not able to generate as much. It's actually formed by the Earth's core, and then it comes up through the layers all the way to the surface. That's where Earth water comes from. Planet X water comes from above. It comes as with the debris field of these objects, and the cores are surrounded in water clouds. And the cloud formed when the planet was destroyed, because that's the way matter acts in the universe. It happens all over the universe. This is why globular clusters turn into stars. Because what happens, and that's what you see there is a globular cluster, is it starts out as a glob of plasma, liquid plasma, and then it creates matter all the time. So it uses up its gravitational energy, creates more and more matter, and that causes the gravitational energy to drop. And when the gravitational energy drops, it fissions. So this big blob of plasma fissions into different pieces. And the different pieces are then the different stars. That's how this blob turns into this collection with millions, sometimes billions of stars. And so what do you expect with the planets? When their gravitational energy was removed, they broke into pieces because the gravitational energy was gone. And the water, which was just liquid water maybe, broke into tiny pieces as well. And if it was in a state where it was frozen, it would have broken into hail. And if it was even in a less dense but frozen state, it would have turned into snow. I don't actually explain that in this one. I just show that what's the difference between the Planet X water and Earth water. And then I explain what is the role of Earth water. And what happens with Earth water is at the surface, some of the water molecules change phase into gaseous molecules. And these gaseous molecules then go into the atmosphere. But water, there I show the Planet X objects in the Earth's atmosphere. And you can see that we are observing them. They are here. They have a cloud envelope. You can see the one on the left is starting to lose its cloud envelope. And they eventually lose it when they've gained enough gravitational energy. And then they become these little pieces of cloud in our atmosphere that gain gravitational energy and eventually turn into a rain or snow or hail and fall towards the surface of the Earth. But you can see where clouds come from. Now, these clouds must gain gravitational energy, and the object itself must gain gravitational energy. And it does so because electrons are carried by Earth water up into the atmosphere. And the electrons do not travel on their own. If there's no water in the atmosphere, like when it's very cold, there's very little water, they remain on the surface. They stuck on the surface. They cannot go into the atmosphere on their own. They have to be carried by the water molecules. And water has two hydrogens in it, and they're positively charged, or that point on the water molecule is positively charged. So they can carry 2 electrons up into the atmosphere.
Can I ask you on this one here, where did you get that? That is very interesting.
I don't remember where I got it from. I think that's one of those images that Scott sent me. It probably someone else sent them to him. But as you can see,
is this a meteorite impact, or what do you think?
No, what this is, first of all, the dark gray part is a stellar core. The bright part is the moon hologram. And you can see that if you try to draw out the rest of the circle on both objects, they do not coincide.
No, they do not.
So they're not the same object. They're not a part of the same object. What it is, there was a stellar core in the atmosphere, and they were attempting to hide its presence by projecting a moon hologram, the crescent of the moon, onto it. That's what happened.
Oh, interesting.
Yeah.
You know, I was looking at the moon last night, Claudia.
Yeah.
And we witnessed a very interesting phenomenon.
Mm-hmm.
It was actually upside down. I got video on it, and it was, it was very, very, very different.
Yeah, it is upside down because it's a hologram. It's a 2-dimensional image in the atmosphere. And what it looks like depends on your position with respect to it. And I've actually written an article about that. You know, if you have an image above you, if you're on this side, you see one image. And if you're on that side, so if you're on this side, there it is. You see this part is below. And if you're on this side, this part of the moon is below. So it depends on where you are. And because it's a projection on the atmosphere, what it looks like depends on where the observer is in relation to it. That's why.
This is very interesting. That one really caught my eye. That one is very cool.
Yeah. Mm.
Yeah. All right. Continue. I mean, I'm going, what?
Yeah. So what happens is the water vapor, which belongs to the Earth, carries these electrons up into the atmosphere, up to the clouds, and then the clouds absorb the electrons and absorb the gravitational energy, which is light within the electrons. And that is how energy is transferred from the core of the Earth, because the electrons have energy from the core of the Earth up to the cloud and the stellar cores up there. And so it's the water molecules that are carrying them. But it's the water molecules are moving upwards to a certain altitude, and that has to do with the gravitational energy in the electrons, because some electrons will have more than others, and electrons are repelled by the core of the Earth because of the charge separation part of the gravitational interaction. So the Earth is positively charged and repels the electrons upwards. And so the moment they have something, a water molecule, to carry them upwards, they turn the water molecule into a negative ion, and it's carried upwards because of the electrons. And this explains what static electricity is. Static electricity is due to the Earth producing electrons that are repelled by the Earth's core. And it explains why the Van de Graaff generator works. And it's explained in exactly the opposite way to which it works. Because what happens is, because of friction, it allows electrons to be picked up by the rubber belt and moved up. They will always move up to the highest altitude they can because they're being repelled by the core. So what we get on the dome, it's always negatively charged particles, electrons. Never positively charged, although they say it's positively charged. This is why, even as a student, I tried to understand how the Van de Graaff generator works. It never made any sense to me. Now it does. It's all to do with what the Earth is producing. The Earth is a battery. It's producing negatively charged electrons, high in gravitational energy. They're trying to get as far away from the core of the Earth as possible, but they cannot do it on their own, so they're carried by water molecules. Or they will be carried by a rubber belt on the Van de Graaff generator.
And every time I see this, I almost see where you could actually generate free electricity.
This is what it's all about, because once you understand that the Van de Graaff generator is the key to free energy. Because, I mean, you could even hand crank this thing. Just get the belt turning. You don't need a motor.
Yeah.
You are producing free electricity by discharging the dome. And guess what? If you put a light bulb close to it, it will light up.
Yes, it will.
It's free energy. It's using the Earth's energy. Earth is like a battery. It's producing energy all the time.
You know, when I got discovered that, Claudia, back in the 80s, I was an observer, an amateur scientist. But anyway, I went out and got one of the neon tubes that you see for fluorescent lights, one of those fluorescent tubes, and stood under a high tension, 50,000 watt high tension line. That son of a gun lit up like the 4th of July.
Wow.
and so when you can begin to see that you can attract electrons through a tube, in this gas, and see the molecules begin to get the electrons, getting active. And I was the conduit. It was, yeah.
I mean, you see, they don't want us to know this, that the Earth is producing all the energy we need, and we don't even need wires. We need wires. We have static electricity. This is what static electricity is. Static electricity is electricity produced by the Earth's core.
It's so, and it just goes to show you, Claudia, how we have become, we're so enslaved. I mean, we pay enormous energy bills when in fact we could do away with that whole industry.
Yes, but the controllers, they don't want us to do that.
They don't like us talking about it either.
Much money out of it so that they can then develop their AI technology.
I think of Tesla. I mean, I really do.
Well, Tesla is the one that invented this.
Yeah, they killed him for it too.
Yeah, because they don't want,
Yeah. We'll move on along so they don't notice us. I had to pull this up, Claudia. This cracked me up. When I read this one, I said, "Oh yeah, we'll have to bring
this." Is unbelievable. That that NASA puts out a lot of pictures that are fake, but they're not this badly done. This is so badly done. It's just unbelievable, Wayne.
So this is the backside of the moon. Is that what they're saying?
Yeah, they're saying this is the backside of the moon.
Really?
So this is the backside of the moon, but the backside of the moon, as you can see, is in black and white. Yeah. So apparently they didn't have color film to take this picture of the moon. You can clearly see it's black and white. This is not an object that just looks black and white. This is a black and white photo. But then they have this Earth there. That's the first thing. That's so colorful. Oh my goodness. How did they manage that? But then
they put that in there?
Hey?
I thought that was like a logo in there.
No, this is supposed to be an Earth-Moon photograph that they took from that the satellite took from the backside of the moon. That's supposed to be the Earth.
Mama, look at that. I did not Why, look at that. You know what?
You thought it was a logo. That's how different it looks. Because it's obviously that they pasted that picture of the moon, the moment you look at it, on that picture of the Earth. It's not even a picture of the Earth. It's a made-up artist's impression of the Earth. But when you look at the edge of the moon...
Oh, we will. I mean, I'm looking at, okay, yeah.
And look at that. There's actually a square pixelated thing around the Earth. So you can clearly see that's something that they made and they pasted it there. But then when you look at the edge of this moon, you can see the pixels, the square pixels, are actually arranged so that they are parallel to the edge. So they follow the edge.
Look at that.
Whilst the other squares that make up the body of the Earth are arranged vertically and horizontally right across. So, the edge is along the horizontal and then the vertical edge perpendicular to that. But on the edge of the moon, it's totally different. The squares are different sizes, and they are parallel to the circumference of the moon. So what they did was they drew some kind of white and black and gray kind of painted thing, and then they applied the pixel effect on top of it. It's an effect. It's not actually pixels. So they apply the pixel effect, and you can see that the pixel effect goes beyond the edge, which is impossible in a photograph. A photograph where it's black, you end up with black, not with pixels where it was black anyway. The same thing with the Earth.
When you pull this out and magnify that, if that's the Earth, then you and I live in a different reality. I mean,
yeah, exactly.
That's just, this is what jerks my chain when I see this kind of stuff. I mean, it takes all the legitimacy, and you can actually see what you're talking about as I pulled out.
Yeah.
But that's just nonsense. I mean,
unbelievable. It's beyond ridiculous, Wayne. I mean, and I say here, this is the same thing as them saying, no, we did not go to the moon or the backside of the moon. This is all a propaganda stunt. And we're telling you the truth with this image. That's what they're saying.
Yeah, what really gets me, Claudia, is the fact that they tried to do this with the moon, and that is just very odd. But this is what really jerks my chain. I mean, let's just say that was the moon. You would lose all credibility of the picture when you see this. If that's the Earth, then oh, come on.
That's what I'm saying, Wayne. There's a message in this because no one can take this seriously. This is beyond, and this is why I say it's beyond fake. This is not just fake. This is beyond fake. This is telling us we're just mocking you, saying that we went to the moon. We didn't really go to the moon, and this is our way of telling you we didn't.
Yeah, this is just, jerking with us. This is, come on.
It is.
Yeah, that just, that.
It's unbelievable. But this was almost the easiest image I've ever analyzed. It was actually fun because it was so easy. I mean, you could see it immediately. It was fake.
Claudia, yeah, that just sucks. I wanted to pull this one up because I found, again, the speed of which things are happening is just amazing. So you get into this because I think so often, we're seeing more and more anomalies. People are catching up with their cameras, and it's always been that they saw it 1 minute and then the next minute it's gone. There's a reason for that, right? The fact that they're moving fast.
Yeah, these objects are moving very fast. So I attempted to put it together, how fast they are moving. And so I explained, first of all, what these are, that they are coming into the Earth's atmosphere, that they have debris, that we have the cores and we have the debris. The cores are positively charged because they have protons in them and not enough electrons. The electrons are not there. But the charge is not exactly the same as their energy level to do with their gravitational attraction. It has to be between protons and protons. And this is what I explain here. So two protons attract each other. That's what gives rise to the attractive gravitational interaction. It's also what gives rise to protons in the nucleus attracting each other. So it's also called the strong nuclear force. But some of the protons are in the form of neutrons. That's why I start calling it nucleon density. A nucleon is either a proton or a neutron. A neutron is made up of a proton and electron. So they have a neutral charge. It's not positively charged like the proton, but the interaction is about the same. They still attract each other because there's a proton inside there. So it's the same as those two those are two protons on the right-hand side. On the left-hand side, we have the electrical interaction where the two protons repel each other. The gravitational interaction, which is on the right, is opposite. They always oppose each other.
Okay.
Yeah, so what we have is particles that attract each other due to having protons in them. And that's where the gravitational interaction comes from. But the debris pieces don't have as strongest charge, and they will also have some extra electrons. So they have less nucleon density, so they have less gravitational attraction, and they have less charge. So, yes, these ones are the stellar cores that go to the sun. The larger ones go to the sun. But there's not actually limit to the size of the object that can come to the Earth. Except that the larger ones are able to get to the sun, so they tend to go to the sun. But that doesn't mean that a large one cannot come to the Earth. One, which may be 4 times the size of the Earth, can come towards the Earth, can interact with the Earth, can absorb energy from the Earth. There's no limit. There's only a limit in terms of the size that can get a certain distance into the solar system. So this is what I show here. So the largest stellar core can get very close to the sun. That's why it shows its orbit. So its perihelion position is always the position beyond which it cannot get any further, any closer to the sun. So that's where it turns around. The larger ones will be the ones that can get very close to the sun, can get the ones that get right into the sun will be the largest ones that have the largest energy in terms of protons, which then gives them the largest charge, electrical charge as well. And they do not come in because of the gravitational interaction. They're not able to interact gravitationally at all. It's only the electrical interaction that brings them in. And when I wrote this article, I wasn't sure of this yet, but I knew that at least it was extremely low. So when I wrote down the equation for the, let's go back. I didn't finish with that diagram. You see the other one, the stellar core one, it's a small one. So it comes in a wider orbit. And that orbit, it just crosses this Earth's orbit. So that one is able to just cross Earth's orbit. It's not able to get any closer to the sun. So the little ones are not able to get to the sun, only the large ones.
I see.
So that's how the size is limited, how the size limits what objects get where. That's why we mainly get little ones coming to the Earth, because they cannot get to the sun. They have too low an energy level to get to the sun.
Interesting.
Yeah.
And you actually did the math on this, right?
Yes, I did. So I put in the charge, because they come to the sun due to their overall charge. The capital Q is the sun's charge, and the little q is their charge. And then there's the gravitational interaction. But I dropped the gravitational interaction because that G is basically zero for them. They're not able to interact gravitational, that capital G. So then I can write down the equation for velocity, which I obtained from the acceleration. And then I drop the second term, and I get an equation for the velocity in terms of the charge and the mass. So this is charge to mass ratio now. And they are related because the mass mainly comes from the protons and the neutrons, and the charge comes from the protons. In other words, the nucleons that still have charge. And I show that for stellar cores of different sizes, the ratio stays the same. That's what that diagram is for. So in a small stellar core, it will have less density. So that means the protons and the neutrons are further apart from each other. But they will have a certain number of protons, certain number of neutrons. And here we have 6 are protons and 3 are neutrons. So the total mass is due to all 9 of them, but the charge only comes from the red ones. So there are 6 charges, basically. When we get to a large stellar core, the ratio stays the same, because even though it's denser, there are more protons and neutrons in the same volume, the ratio basically stays the same. There's the same relationship between protons and neutrons. It's not likely to change. It only changes when an object gets older, where they will have more neutrons than protons, or the other way around. But you have to assume these are about the same age. So that means the charge to mass ratio stays the same for the stellar cores. So that means the stellar cores will go through Earth's orbit as they cross Earth's orbit at the same speed, because that stays constant. But the debris pieces will have a lower charge to mass ratio. So they will move at lower speeds. So the stellar cores are the objects that are moving the fastest. The debris pieces will move slower when they cross Earth's orbit. And then I estimate how fast are these debris pieces moving, because the debris pieces, the fastest moving debris piece that has ever entered the Earth's atmosphere was moving at about the same rate as the Earth's orbital speed. But it would have to be moving at least twice that in order for it to seem to be moving at Earth's orbital speed from the Earth. So then I calculate how fast that debris pieces, the maximum speed these debris pieces are likely to move at. It's about 68,000 miles per hour. No, that's how fast this was moving. So that means these pieces would be moving twice as fast. So that's 134,000 miles per hour.
Holy crap.
And so the stellar cores will be moving faster than that when they cross Earth's orbit. So they're very fast moving.
Wow. Claudia, I think tonight we've probably had more math than we've ever had.
Yeah, sometimes I can't help it. But
no, I think
I
that
have to do a little bit.
well, I think that this brings to point that, you are a PhD particle physicist.
Yeah, I mean, I do try to keep it as simple as possible. Sometimes it's unavoidable. I have to do a little bit of math to come up with some numbers.
So I always like it for those who always want to, give us a hard time that, all right, now, guys and gals, come up with your own math formula.
Yeah.
Yeah. Oh, well, now you're going to get technical on us. Oh, Claudia,
Yeah,
thank you. This has been, I get to read these folks, and, the math, when I see it, now that you explain it out, so I understand what the variables are, you can see the rationale.
Mm-hmm.
But it takes a teacher.
Yes.
It does. It does.
Yes. I love teaching. Because I learned so much from teaching. It's when I think, well, I have to explain this properly so people understand, that I see the connections even better.
Mm-hmm.
It's and this stuff is getting complex now. I must say, I'm starting to put things together, and it's getting to a level of complexity that I didn't have in the beginning. And it is getting more difficult to explain. So especially for people that haven't been following this, it's getting more and more difficult. I sometimes put a whole article together, and then I think, oh my goodness, I have to break this up into 2 or 3 articles.
Well, I love it because, Dr. Albers, it validates why you can be called Dr. Albers, is that people so often, and you and I have known each other for a while, that we've seen the trolls, we've seen the critics, but yet now that you're bringing the complexity of the math into the equation, I want to see how those who are the contrarians, let's see your math.
Yeah, well, they usually try. And the way I see it is, if I get lots of troll comments, I think, oh, wow, I really hit it on the nail.
I love you, dear. I'll tell you what.
I really hit it. I really got something that really bothered the system. It must be too much truth in it.
See, folks? That's how you take the negative and you make it into the positive.
Yeah.
Claudia, it's been another great hour, my dear. Thank you so much.
Thank you.
You grace us each week, and you share your knowledge. And that's what I love, because everyone who sticks with us, they're getting a lot smarter now. They can go back and replay these, and they go back and see how the math works, how the rationale is working. And now they can begin to draw their own conclusions, although most of us would have to be on a 747 to catch up with you, but that's okay.
Well, I love it when people leave comments and say, wow, I understand something now that I didn't before. Yeah. It's like when I was lecturing, I used to look at my students, and I could see when the light comes on. And that was, I lived for that,
Yes. Yeah.
For seeing that light come into my students' eyes as they understand it. Wow, I understand that.
I mean, I'm smarter already, It's like, okay, I can tell you exactly how the math works. I love this.
Yeah.
Well, everyone, make sure you subscribe to Dr. Albers' channel. I just appreciate Claudia every week coming together. I really do.
Oh, I nearly forgot.
What's that?
I have a new book.
Well, why didn't you say?
Yeah, I forgot.
At that. Wow, that one is cool.
Yeah, so Planet X reveals how the universe works.
Will you send me the link, and
yes.
I'll put it in when I repost this? And
okay.
Wow, all right. Now, can that be bought on Amazon?
Yes.
Excellent. Okay. She is a true teacher. Brad White says Dr. Albers is a true teacher. Yeah. Just be thankful that she isn't giving us homework.
Yes. That I believe that homework is good for you, but I cannot force
You
it.
know what we ought to do? One of our shows on is just let you use the whiteboard function in Zoom and just begin to teach everyone some basic principles of basic physics. How do we establish the criteria of determining, for instance, the circumference of the Earth? How do we put that into a symbol that represents the equation? Those are the type of things that I think would help so much for all of us. What do you think?
That's a good idea. That's a good idea. Yeah.
Well, how about next week?
Mm.
Think about it. I'll just turn it over to you, and you just take the hour and just teach us all some basic physics of understanding how to calculate things. I mean, we all observe things. How do we express it?
I always started my courses with a mathematical introduction. It always
Let's do
had
that.
to be done.
Yeah.
But I can do something like that.
I'd love it. I think our audience will too. Look,
I don't know how to use this whiteboard thing.
I'll show you. It's actually what you do is in the annotation on Zoom. But
okay.
Yeah, I can turn it over to you. And
it's just a little bit difficult to use mathematical symbols sometimes.
Oh, that's true.
So I probably have to put an article together.
I think you probably would. Yeah. Although I have to say, putting a whiteboard behind you with a camera on it would be pretty damn cool.
Yeah.
I mean, hello, Scott.
I don't have a whiteboard anymore.
Scott, we could use a whiteboard that has a camera so Dr. Albers can get up there and do her equations and then have I'm just we're going to get that. We'll get it somewhere.
I used to have whiteboards everywhere. I had it in my office at the university. But
my offices as a CEO, we had the walls literally covered in whiteboard. I mean, because I'm the type of person, if I have a thought, I always like writing it down. And I encourage that in my employees. And I'll tell you, it got very interesting. You see these engineers and they stop and just, so yeah. Well, Claudia, thank you. Thank you so much. Thank you. Thank you, everyone.
You. It was lovely.
Well, give my best to Scott. We'll have to get him back on, but I really would like the idea of the class idea. I think that would be so cool.
Yeah, I'll have to think about it. I mean, what kind of things you would like, because there's so much. You'd like something like the circumference of the Earth. And
maybe that's what I
actually have written an article that explained how the Greeks calculated the circumference of the Earth. But I can
Let's do that. I think that would be fabulous. I mean, seriously, it would certainly get us. All right, so see there's something. All right, Dr. Albers, thank you.
Thank you.
And everyone, thank you. And we'll see you next week. I'm going to bring pencil and pad with me next week.
Okay, good.
Okay. All right, everyone. Thank you all. Claudia, I'll see you next week as well, my dear. Thank you. Bye-bye, everyone. Bye.